Today we are going to be talking about transformations. We are going to break up our transformations into the graphs that are more similar to each other. So we're going to today focus on sine and cosine. Then we'll move on to cosecant and secant later on because those two are pretty similar. And then we'll look at tangent and cotangent. So today we're going to focus just on sine and cosine. A lot of what we do today is also going to be a lot of focus on how do we call these different transformations. We've seen all these transformations before, but some of them have different names in the context of trigonometric functions. So we're going to start with what we call amplitude. Now the amplitude of the sine and cosine graphs that are given here is half the distance between the maximum and minimum values of the function, and it's given by the absolute value of a. Okay, so the amplitude is half the distance between the max and min values of the function and given by the absolute value of a. So in terms of a diagram, let's say you're looking here at the sine function. We say the distance from the max to the min is from here to here, and the amplitude is half of that distance. Now, the reason why I'm not telling you it's the measure from 0 to the max or 0 to the min is because there could be other transformations that make this or that force this entire graph to be, let's say, shifted up a lot further. Let's say it's not even touching 0. So we can't use 0 as a good starting point because we are going to have different transformations in addition to transformation of the amplitude. So the easiest thing to do is to look at what the distance is from the max to the min and then find what half of that is. Another way you can do it is you find the distance from the max to the min and figure out where the middle of the graph is. And from the middle of the graph to either the max or to the min, that is going to be your amplitude. Okay, so in example 1, sketch the following functions: y equals 1/2 sine of x, y equals 3 times sine of x. So here is our parent function, just y equals sine of x, where the amplitude is 1, right, because a is 1 times sine of x. So 1/2 times sine of x means that 1/2 is going to be the distance, half the distance between the max and the min. Now, if we are just looking at this as a transformation on its own, you can absolutely say, oh, it goes up to 1/2 and down to negative 1/2. So you can absolutely think of it that way here. Just know that in the future, it might not be quite as easy if, say, for example, the function has been shifted up or shifted down. One other thing to notice is if you compare the parent function to this function that has an amplitude of 1/2, you'll notice that the x-intercepts are still in the same place, right? So it's the max and the min points that have been reduced. So if you go to y equals 3 times sine of x, the same thing's going to happen. It's still going to start at 0. It's still going to cross the x-axis at pi and at 2 pi. The only difference is it's going to have a max all the way up at 3 and then all the way down to negative 3. Another way to think of this is really just a vertical stretch or shrink, right? That's really what we're doing here. But a lot of the times when we're talking about trig functions, when we talk about applications, a lot of the times we use the term amplitude. And so it's good to see that this is really just a vertical stretch or a shrink, but also know that it's used as the term amplitude more often than as a vertical stretch or a shrink of the graph. All right, the next thing we're going to talk about is the period of the function. So we talked about how the period of sine and cosine is normally 2 pi, but we can change that. So the period of the sine and cosine graphs is the length of one full cycle of the graph given by 2 pi over b. Now you'll notice with these equations, I'm slowly adding in more and more things. So whatever the b value is in there, inside the function, the b value itself does not give you the period, but you use that to find the period by doing 2 pi divided by b. Right, so if b is equal to 1, then well, really you just have the parent functions, right? Sine of 1x is the same as sine of x. And so for the parent function, 2 pi over 1 is 2 pi. That's the normal period of a sine or a cosine graph. But if you had b is equal to 2, then you have 2 pi divided by 2, which gives you pi. So then the length of one period is going to be pi instead. Okay, so here's a picture. So the period of the function is this length here. And normally it's 2 pi because 2 pi over 1 is 2 pi. But we can change it. So it could be either a longer period or it could be a shorter period. Let's take a look at example 2. We have y equals cosine of x over 2. Now you can think of this as cosine of 1/2 times x. Now let's see. If we graph our regular parent cosine function, this would go from 0 to 2 pi. But now our period has changed. Now our period isn't 1/2, but 1/2 is going to help us determine the period. So the period is 2 pi divided by b, in this case 1/2, and 2 pi divided by 1/2 is equal to 4 pi. So this means that instead of the period being 2 pi, it's now 4 pi, so it is that one cycle is now being stretched out, so it won't return back up to 1 until you get to 4 pi. So that's what the graph would look like. You can also think of this as just horizontal stretching and shrinking. That's really what it is here. But more often than not, when we talk about sine and cosine transformations, when we talk about sine and cosine graphs, you are less likely to hear about horizontal stretching and shrinking and more likely to hear about the period of the function instead. All right, the next thing we're going to talk about are translations. So we're going to add a little bit more to our equation here. The sine and cosine graphs will shift horizontally to the right by c units if c is greater than 0, and to the left by c units if c is less than 0. Now notice here that the way that I've written it, that seems like normal, but if you look at the equation, it says x minus c. So the same still applies with transformations. If you see x minus a number, right, x minus a positive number, that's going to shift to the right. If you see x plus a number, that's really x minus negative whatever the number is, so that's going to shift it to the left. So if it's helpful, just think of right and left being the opposite of what you naturally think. So if it's minus a number, it shifts to the right. If it's plus a number, it shifts to the left. So here's a graph that if you were to shift it horizontally, this is what it would look like. Now we could also have a shift that's a vertical. So this is a horizontal shift, but we can also have a vertical shift. So we would say that the sine and cosine graphs shift vertically up by d units if d is greater than 0, and down by d units if d is less than 0. Now again, pay close attention to the equation itself. It says plus d. So this is only going to be the case if you are adding d. Then if d is greater than 0, it's going to shift up. If d is less than 0, it shifts down. So this is, as opposed to the shifting left and right, the horizontal shifts, shifting vertically is more naturally what you imagine when you imagine that plus a number shifts it up and minus a number shifts it down. So here is an example of a sine function, and if we shift this entire thing up vertically by d units, this is what it would look like. Okay, so let's take a look at example 3. It says determine the horizontal and vertical shifts in the following sine equation. Now, one important thing to note is that in the form that I've been giving it to you, the sine and cosine functions with the transformations have been given to you in the form where inside the sine function, the b value is factored out. So if you look at this one, we have y equals 4 times sine of 3x plus pi, in parentheses, minus 2. We need to factor out the 3 from both terms inside the parentheses. So factor the 3 out, we're left with x and pi over 3. Now, we are trying to determine just the horizontal and vertical shifts, so we actually don't need to worry about the amplitude or the period in this case. So in terms of a horizontal shift, it looks like that pi over 3 is going to tell us it's going to shift to the left by pi over 3. And then the minus 2 at the end there tells us that this is going to be a vertical shift down 2. All right, lastly, we're going to talk about reflections. So if you have negatives either on the function itself or inside of the function, they will be reflections either across the x-axis if the negative sign is on the function, and across the y-axis if the negative sign is inside the function. So here's an example of our sine function, and if we had a reflection across the x-axis, that's what it would look like. Now you'll notice that for the cosine function, because it is an even function and has symmetry with respect to the y-axis, if you were to take the cosine function and reflect it across the y-axis, it would actually look exactly the same. It would just be reflected back onto itself. So there are some cases in which reflecting it might not change anything. It really just depends on the graph, depends on which axis you are reflecting it in. Okay, example 4. In this problem, you are going to write the equation of the sine function that gives the graph below. Now, as you know, sine and cosine are really just, in terms of the shape of the graph, they're really just the same, except that one is shifted over to the left or to the right, however you want to see it. So anytime you're asked to write an equation for one of these graphs, you actually won't be able to tell if it's sine or if it's cosine, and both are acceptable. The only exception is if you're asked specifically to write it as a sine or a cosine function. So in this case, you're asked to write it as a sine function. Okay, so the first thing I would do is I would try to find where the middle of this graph is. So I see the lowest point is at 0 and the highest point is at 6. So I know the middle of this graph is going to run at 3. So I'm going to draw a horizontal line at 3. What this does is that it helps us determine exactly what the amplitude is. It also helps us determine how much this graph has shifted vertically. So let's start with the amplitude. So the amplitude, remember, is half the distance between the max and the min. So you could say, okay, the max and the min, that distance is 6 divided by 2 is 3. At this point, because you also have that horizontal line drawn in the middle, you can also just find what's the distance from that line to the max or that line to the min. Either case, you'll get 3. Okay, now let's look at the period of the function. So I like to start at 0 and see where does my graph take me back to that point again. So in this case, it starts at 0, 0, goes all the way up to 6, and then all the way back to 0, a distance of pi. So our period is pi. Now, in terms of coming up with an equation, we know that b is not going to equal pi. What we need to do is we need to determine what b has to be in order for the period to equal pi. So remember, the period is given by 2 pi over b, and in this case, 2 pi over b is equal to pi. So that means b is equal to 2. Now, the reason why I put absolute values in there is because you could have a negative in front of the b, but that indicates a reflection. All right, next let's see if we can find a horizontal shift. Now, if we see this as a sine function, you can see this as a horizontal shift to the right by, and if you look and see where this function crosses that middle line, It happens at pi over 4. So that point there is normally where the sine function begins, right, at 0, 0. But now that point is at pi over 4 instead of at 0. So we would say that this function has been shifted over to the right by pi over 4. Now it is possible to see this as a different kind of shift. You could see it as a shift to the left by 3 pi over 4, right? Again, you can see that starting point right before it starts going up to the maximum value, the place where it hits the midline before it hits the max is at negative 3 pi over 4. So you can also see this as a shift to the left by 3 pi over 4. So just so you know, there are different ways of coming up with a horizontal shift. I personally like to keep it as simple as possible, so I like to find the place where it is closest. So shifting it to the right by pi over 4 is a shorter distance than shifting it to the left by 3 pi over 4. But by no means is shifting it to the left by 3 pi over 4 incorrect. All right, for the vertical shift, this is actually pretty easy if you have drawn that midline in. Really, that midline is normally the x-axis, and so for the sine function, you can see that the entire function has been shifted up by 3. So really, just look at where that middle line that you've drawn is, and that's going to tell you where your vertical shift has shifted. And then in terms of reflections, based on what we've done here, there are none. Now obviously there are other ways to write the same function but with a different equation. So you could see this as, let's say instead of a sine function, you saw it as a cosine function. Well, as a cosine function, you can either say it has shifted to the right by pi over 2, or instead of shifting it horizontally, you can actually just say it has been reflected. So there are ways to get around with not having to deal with any reflections or not having to deal with any horizontal shifts. It just really depends on your preference and how you prefer to see how the function has transformed. So putting this all together, let's go ahead and write our equation. So y equals 3 times sine of parentheses 2, parentheses, x minus pi over 4, parentheses, parentheses, plus 3. All right, now let's talk about some applications of sine and cosine graphs. So a couple of tips. You can use either sine or cosine unless otherwise indicated. So unless I tell you specifically use a sine graph or use a cosine graph, then it's really up to you which one you want to use. Now since these graphs are just shifts of each other anyway, it doesn't matter which function is used. There are multiple correct answers. So when you do applications, you come up with an equation. You could come up with a different equation than someone next to you, but it could still be correct. It really is a matter of, well, if you use sine, if you use cosine, you could shift it this way, or you can see it as a reflection. There are multiple ways of coming up with correct answers. I would also say to determine what the high and the low points are that are given to you. Now, in terms of, is it easier to use sine or easier to use cosine, it really depends on the problem. Sometimes, if you are told that the high is this and the low is this, or the max is this and the min is this, I like to use cosine for that because the cosine parent function starts right at the max. If you're told this is where the middle point is and then it goes up as high as this and as low as this, then I like to use the sine function because then we can incorporate the use of that middle line. Let's take a look at example 5. The depth of the water at high tide occurs at 4:15 a.m. and is 5.2 meters deep. The depth of the water at low tide occurs at 10:27 a.m. and is 2.0 meters deep. Find the trig equation in terms of cosine that models this relationship where x represents hours after midnight. Okay, so because it tells you to use cosine, let's go ahead and draw ourselves a cosine curve. Now, I'm not going to label the x and y axes just yet because we have specific values that are given to us and we want to use that. But we have the general shape. Now we know that here, this high point here, that is the depth of the water at high tide. And down here, that's going to be the depth of the water at low tide. So at high tide, that's 5.2, and at low tide, that's 2.0. Okay, now we remember, just like we did in the other example where we were trying to find that middle point, to help us find the amplitude, it helped us find the vertical shift. So let's find the middle point here. So to find the middle point, that's whatever is halfway between 2 and 5.2. You can think of this as finding the average of those two numbers. So 2 plus 5.2 is 7.2, divided by 2 is 3.6. Okay. Now, from here, we want to go ahead and say, okay, well that means that the amplitude, that distance, half that distance, is going to be what? Is going to be 1.6. Now how do we get that? Well, between 5.2 and 3.6, you do 5.2 minus 3.6, and that gives you the difference of 1.6. Another way you could do it is you could do 5.2 minus 2, that's 3.2, and take half of that distance, that's 1.6. Okay, let's continue. So here at this point, this high tide occurs at 4:15 a.m. Now, we're being told that X represents hours after midnight. So 4:15 a.m., be very careful here, because this is 4 hours and 15 minutes. We want to change this all into hours. Now remember, 15 minutes is a quarter of an hour. So 4:15 a.m. is actually 4.25 hours after midnight. Now we want to do the same at 10:27 a.m. That is 10 hours and 27 minutes. Now 27 minutes, put it over 60 to determine exactly how, what fractional part, what decimal part of an hour that is, and that should give you 10.45. Okay, from there, if we were to double that distance from 4.25 to 10.45, that's a distance of 6.2. So until it gets back to high tide, that's another 6.2 hours, which means that this entire distance here is 12.4. Now you know that this distance represents the period of the function. Okay, now we actually have all we need to come up with the equation. So we said the amplitude is 1.6. Now the period we said is equal to 12.4. So 2 pi over b equals 12.4, which means b is equal to 2 pi over 12.4. Now you can feel free to simplify that if you like, but you can leave it as 2 pi over 12.4 if you'd like as well. Now in terms of c, how much has it shifted right or left? Really you can just see that if we're using a cosine function to model this, then really you're just seeing, okay, where is that maximum point starting at? It starts at 4.25, so you can think of this as a cosine function being shifted to the right by 4.25. And then d, how much has it shifted up or down? You can just look for that middle line that we created before, which is at 3.6. Normally that middle line is the x-axis, so that means that this function has shifted up by 3.6. All right, now we're ready to put it all together in an equation. So y is equal to 1.6 cosine of 2 pi over 12.4, parentheses x minus 4.25, close off that function, and then plus 3.6. And that is the function that you can use to model this high tide and low tide with the information given.